Hello friends, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about coordination compound. Complex compounds are a special class of compounds in which the metal atom ions are bound to a number of anions or neutron molecules. You know friends, in modern terminology, these compounds are called coordination compounds. Coordination compounds, complex compounds are a type of additions compounds. You can look this picture and you can see here dative or coordinate covalent bond. In center metal ion and the green one is ligand. So, on the basis of nature, addition molecular compounds are divided into two categories. They are double salts and coordinations or complex compounds. So friends, what's the difference between double salt and coordination compound? The first difference is these exist only in solid state and dissociate into constituent species in their solution. Coordination compounds retain their identity in solid as well as in solution state. Double salt lose their identity in dissolved state. Coordination compounds do not lose their identity in dissolved state. Double salt properties are essentially the same as those of constituent species. Coordination compound properties are different from those of their constituent. For example, K4FeCnO6 does not show the test of Fe2 plus and cyanide ion. Double salt, the metal atom or ion exhibit normal valence. In coordination compounds, the number negative ions or molecules surrounding the central metal atom is beyond the normal valence. So this is more salt, ferrous sulfate, ammonium sulfate, and 6H2. Now, double salt and coordination compound. For example, an aqueous solution of potassium alum will give the test for potassium, aluminum, and sulfate. You can see here. On the other hand, coordination compounds are molecular compounds that retain their identity even when dissolved in water. So, when potassium ferrocyanide is dissolved in water, it does not give the usual test for Fe2 plus and Cn minus, indicating that FeCnO6 4 minus does not dissociate into Fe2 plus and cyanide. So, you can see the coordination compound. Coordination compounds that have a complex ion are called complex compound. As the central metal ion in complex ion forms dative or coordinate covalent bonds with the species surrounding it. You know friend, complex ions are also known as coordinate ions, and hence the corresponding compound are known as coordinate compounds. Now, Werner theory. Alfred Werner, Swiss chemist, but forward a theory to explain the formation of complex compounds. It was the first successful explanations because became famous as the coordination theory of the complex compound, which is also known as Werner's theory. So what is the postulates? The first postulate, the central metal ion atom or ions in a coordination compound exhibits two types of valences, primary and secondary. Primary valences are ionizable and corresponding to the number of charges on the complex side. Primary valences apply equally well to simple salt and to complexes and are satisfied by negative ions. Now friends, secondary valency correspond to the valency that metal atom or ion toward the neutral molecule or negative ions in the formation of its complex ion. So, secondary valencies are directional and so the complex has a particular shape. The numbers and arrangement of ligand in a space determines the secondary chemistry, stereochemistry of complex. Now, Werner theory, the postulate of Werner coordination theory were actually based on experimental evidence rather than theoretical. Although Werner's theory successfully explains the bonding feature in coordination compounds, it has drawback. What is the drawback of Werner theory? It doesn't explain why only certain elements form coordination compounds. It does not explain why the bond in coordination compounds have directional properties, and it does not explain the color and the magnetic and optical properties of complexes. Now, friends, Werner modern electronic theory of valence. You can see outer sphere, you can see inner sphere. You can see outer sphere ionization sphere. So application of Werner theory to cobalt 3 amine. You can see you have cobalt 3 6 ammonia, cobalt 2 5 ammonia, cobalt 3 4 ammonia and cobalt 3 3 ammonia. So what happened? Cobalt 3. If you give the test and you find no silver chloride test, 1 silver chloride, 1 chloride ions, 2 chloride ion, 3 chloride. Friend, on heating with a Cl at 373 Kelvin, cobalt amine does not evolve ammonia. Primary valence of cobalt is 3 and secondary is 6. All the compounds differ in their reactivity. Now, Werner theory. Werner proposed the putting all molecules and ions within the sphere in bracket, and those free ions that dissociate from the complex ion when dissolved in water outside the bracket. So original formulations, color, lone pair formula, ions pair formula, and free chloride ions per formula unit. Now friends, ligand, what is this? The molecule or ions which are coordinated to metal atom or ion. For example, K4FeCN6 and 6 cyanide group coordinated by Fe2 plus and are the ligands. Ligand can be negative ions, positive ions or neutral molecule. Ligands are Lewis base, central metal atom or ion is Lewis base. Now, types of ligand: mono or unidentate ligand, poly or multidentate ligand, ambidentate ligand. If a ligand has two or more donor atoms, complex is formed only one donor atom is attached to thiametal. So, one donor atom or one point of attachment and can coordinate with the metal ion at only one site in a complex. So, Poly or multi-dentate ligands or more donor atom or point of attachment polydentate ligands are further classified as bidirectional. Now coordination number of ligand atom bonded directly to the central metal ion, specific for organic or given metal ions, in particular oxidations. Geometry of complex is related to cyanide. Coordination number 2 linear. Coordination number 5 trigonal bipyramidal, square pyramidal, octahedral, and you can see the tetrahedral and square planar. So a complex ion has a metal ion at the center with a number of other molecules or ions surrounding it. So coordination entity. What is coordination entity? Metal atom or ion bonded to fixed number of ions or molecules. For example, COCl3, ammonia 3, fixed chlorine and ammonia ions. So you see the oxidation number, coordination number, etc. Now homoleptic, one kind of donor groups attached to the metal ions or atom. You can see the homoleptic, heteroleptic and asymmetric. Charge number of complex ion. The net charge carried by complex ion. Charge number of FeCnO6. Charge of Fe2 plus 6 charges on chlorine ions, and plus 2 plus 6 is minus 4. You can see the minus 4. Coordination polyhedron. The spatial arrangement of ligands atom directly attached to the central atom or ion. Square planar, tetrahedral, trigonal, bipyramidal, square pyramidal and octahedral. So Sidgwick electronic theory. The ligand donate the electrons here to the central metal ions and thus form a number of coordination compounds. So friends, effective atomic number EAN, Z minus X plus Y, where Z atomic number of metal, number of electrons lost during the formation of metal ion from its atom, and number of electrons donated by the ligands. For example, you can see. Now, nomenclature writing complex compounds. The formula of cation, where it is simple or complex, is written first followed by that of the anion. Within a coordination sphere, the metal atom as well as the ligand are listed without any space between them. So friends, nomenclature. In ionic coordination compounds, the cation is named first and separated by a space from the anion. You can see this picture. If the coordination entity is either neutral, cationic, then usual name of the metal is used, but when the coordination entity is an anion, then name of the metal ends with the suffix. So friends, lithium hydroaluminate, sodium hexanitrate to N diamine silver 1 nitrate, potassium tetracyanoate and tetracyclonickelate. So isomerisms in coordination compound I will discuss in next lecture. So friends, if you like this video, then subscribe my channel, and thanks for watching.